Hey guys, I'm hoping that you had a great spring break. What I want to get into today is going to be part one of our forensic serology unit. We only have 2 units left for the rest of the semester. That is going to be forensic serology or blood. And then we have ballistics is going to be our last 2 units of the year. So this is going to be part one of your notes on blood typing. So I want to get through it. And then you guys have a blood typing activity that you're going to do today. All right, so let's get into it. So when we talk about blood typing, we talk about a specific system known as the ABO system. It was developed by this gentleman named Karl Landsteiner around the 1900s. He discovered that there are 4 different types of human blood. If you guys can remember back to the very beginning of the semester, we did talk about the history of forensic science, and Karl Landsteiner was one of the dudes on the list. So basically, what he was the first person to do is he made the distinction based on agglutinogens, or also known as antigens, that are on the surface of red blood cells. So based on what he determined, there are 4 different types of blood. That would be type A, type B, type AB, and type O. We're going to get into how antigen and antibodies work. What I want you to think about is antibodies are, let's just say, a flag for our body. So antibodies are going to tag foreign invaders by binding to them, and it basically tells the body, yo, you need to get rid of this because this is foreign and it doesn't belong here. This is going to be a big deal when we talk about who can donate blood to who and who can receive blood from who. All right, so like I said before, there are 4 different blood types. We're going to go through each of them and their characteristics. Please make sure you pay attention to this because you're in your quiz or test. I'm going to give you a person and I'm going to say who can they receive blood from or who can they donate blood to. So this is information that you're going to need to know. All right, so when we talk about a person that has A blood, they have A antigens on the outside of their erythrocytes. Those are your red blood cells. And they are going to have anti-B antibodies in the plasma, okay, because they're trying to defend against any other foreign blood that would be inserted into your body. So that's why if you have A blood that has A antigens, you're going to want to have anti-B antibodies to get rid of those B antigens. We'll talk a little bit more about that in a minute. But they can give blood to a person that has A blood, a person that has AB blood. Okay, those are the only 2 people that a person that has blood type A can donate blood to. But they can receive blood from a person who either has O blood or has A blood. And we'll talk about some of the individual differences. I know you guys are like, well, I'm AB positive. Okay, we'll talk about what that means in a minute. When we talk about B blood types, they're going to have B antigens on the outside of the red blood cells. That means that they're defending against everything except itself. That means it's going to have anti-A antibodies in the plasma to defend itself. They can give blood to people that are B or AB, and then they can receive blood from someone who is O and someone who is B. The last 2 of the 4 are going to be AB, and they're going to have A and B antigens on their red blood cells. Now here's the deal. Because they have A and B antigens on the outside of the red blood cells, if they had anti-A or anti-B, they would be attacking their own antigens on their red blood cells. So anybody who is AB does not have either anti-A or anti-B antibodies in their plasma. Now, AB is kind of tricky, right? They can give blood to a person who is AB and AB only, but they can receive blood from everybody. They can receive blood from an O person, an A person, a B person, and an AB person, okay? That happens because they don't have any antibodies that are going to attack any of the types of blood. Okay, that's what makes them the universal receiver, okay? Meaning that they can accept blood from anybody. When we talk about O, they don't have any antigens on their erythrocytes, okay? So with O people, it's exactly the opposite. They're going to have anti-A and anti-B antibodies in the plasma. For their blood, it does not matter, right? Because they don't have any antigen on the outside of their red blood cells for anti-A or anti-B antibodies to attach and basically attack. So they are what we call the universal donor, meaning that they can give blood to an O person, an A person, a B person, or an AB person. Unfortunately for them, they can only receive blood from an O person. Okay, we'll talk about the different percentages of blood types in the population, but O is definitely more prevalent. Okay, so here is a diagram just so we can break this down for you. So let me give you an example of what your situation would be if you are a person that is group A blood. If you have group A blood, this is what your red blood cell looks like, right? You have what we'll call A antigens on the outside of your red blood cells. So this is the magenta circle up here at the top. The antibodies in your plasma are going to be anti-B. Okay, so you're going to be attacking anything that has a B antigen on the outside of the cell. Okay, if you had anti-A, you would be attacking yourself, which is why you're anti-B. This is just showing you what the antigen looks like in the red blood cells, and we have this magenta circle or sphere. When we talk about group B, you are going to have your erythrocytes, but they're going to have a different antigen on the outside. So this one is represented by a diamond here. You are going to have anti-A to defend yourself, because if you had anti-B, you would be attacking yourself. Okay, so the antibodies in the plasma of a person who has B blood is going to be anti-A. And this is just a diagram showing you what the B antigen looks like. When we talk about AB, if you look, they have both the magenta and they have this teal diamond shape on the outside of their erythrocytes. That is to represent A and B antigens. Now, because of that, if they had any antibodies in their plasma, they would be attacking their own blood, which is why they do not have any antibodies in their plasma. When we talk about group O is not going to have any antigens on the surface, so it's okay if you have anti-A and anti-B, because you're not going to attack yourself, right? Because you don't have any antigens on the outside of your red blood cell, okay? Hopefully that was helpful. You guys will be doing an activity today, which hopefully will smooth things out for you. So here is a figure just showing you basically everything that I just said. I've just put it into, let's say, a simpler chart. So I'll break it down one more time. If you have blood type A, you are going to have A antigens on your erythrocytes. That means that you want to attack anything that is not A, which is why you have anti-B. And you can give blood to A, AB, and you can receive blood from O, or a person who has A blood. For blood type B, you are going to have B antigens on your red blood cells, right? You're going to want to attack everything that is not B, because you do not want to attack yourself, which means you're going to have anti-A antibodies in your plasma. You're going to be able to give blood to people that have B blood, AB blood, and you're going to be able to receive blood from people that have O blood and B blood. For AB, the antigen on the outside of the erythrocytes are going to be mixed, both A and B. Because of that, you do not want to have any antibodies in your plasma, or else you'd be attacking your own blood. So you do not have anti-A or anti-B antibodies. You can only give blood to people who are AB, but you can receive blood from everybody, okay? So you can receive blood from somebody who is O, B, A, and AB. When we talk about O, you're going to have neither A nor B antigens on your red blood cells. That means you're going to have both anti-A and anti-B, because you're defending against both of the other antigens. And you'll be able to give blood to people that are O, people that are A, people that are B, people that are AB. And then you'll only be able to receive blood from people that are O, right? So hopefully that broke it down a little bit further for you. Now let's talk about what we're doing when we're testing for these things. So like I was saying before, we were talking about population frequency. So blood type O, which is going to be characterized by the absence of A and B agglutinogens, it is going to be the most common. Almost half the population of blood type O, so that's 45%. Blood type A is going to be characterized by the presence of A agglutinogens. That is about 40% of the population. The exact number is going to be 39. Blood type B and blood type AB are going to be the least common. We have B at 12%, and then we have AB is about 4% of the population. These numbers may have slightly changed. I mean, I think they're about 5 years ago is when I got the numbers. So normally the numbers stay pretty consistent, but there might be a slight difference now. Okay, so let's talk about how we test. So we are going to test using this process of agglutination. So it's a very simple test. We are going to take samples of the blood, and then we are going to add each of the anti-serum to the blood samples. So we will have a drop of blood, we'll add anti-A, then we'll add a drop of blood, and then we'll add anti-B, and then we'll add a drop of blood, and we'll add anti-RH. Now what we're looking for is when that antibody binds to the antigen, it's going to call what we call agglutination or clumping. And that's going to tell you they had that type of blood. So for example, if somebody has A blood, I put 3 drops into a tray, I add anti-A, I add anti-B, and I add anti-RH, okay? I see some sort of clumping or agglutination. It should happen in the slot where I put anti-A, which tells me that the anti-A antibody bound to the A antigens on the outside of the blood cell and cause this clumping. And that's how I can determine if the blood type is A or not. Okay? So in terms of results that you would see in testing, if you have blood type A and I add anti-A serum, you should see this agglutination or this clumping. If I add anti-B, remember, anti-B is going to attack blood type B. So if you don't have blood type B, it's not going to attack it. You won't see any clumping, and we call that no agglutination. Same thing down the line for all the other blood types. For B, if I add anti-B binds to B, I will know that your blood type is B. Okay? And I'm going to see that clumping. Same thing for anti-A. If I add anti-A to somebody who has a B blood type, I won't see any clumping. For AB, because you have both antigens on the outside of your red blood cells, I'm going to see agglutination with both anti-A and anti-B. And then for O, you do not have any antigens on the outside of your red blood cells, so I shouldn't see any agglutination whether I use anti-A or anti-B. All right, hopefully that was a little bit easier for you, or cleared some things up for you. The last thing I want to talk about is the genetics of blood types. So I'm sure you guys remember maybe from biology when we talk about homozygous and heterozygous. Well, A and B are considered homozygous and heterozygous, right? So we have IA and IA is the homozygous. And then we have IA little I, and that is the heterozygous version. Same thing with B. We have IB and IB. And then we have IB and little I. For AB, you guys might remember from biology this thing called codominance, right? We have IA and IB, which are both present, which gives you the AB blood type. And then we have little I, which is the recessive blood type, which represents O. All right. So the last thing I want to talk about is this RH system. So there are going to be 6 antigens in all. You can see them listed right there. D is probably the most common, as you can see. Excuse me. 85% of Caucasians are going to have D. 95% of African Americans are going to have D. And then we have 99% of Asians are going to have D. There are going to be at least 8 alleles for the RH factor. And then you need to know that Rh positive is going to be more dominant over Rh negative. So, unlike the ABO system, individuals who lack the D antigen do not naturally make it, okay? So your body isn't trying to fend against anti-Rh, okay? Production of the antibody to D is going to require exposure to that antigen. And here's what happens. When your body is exposed to it, you will make an antibody for it. So, for this reason, all individuals that are typed for D, if negative, must receive Rhd negative blood. We never want to give somebody a reaction or cause their body to create antibodies for that particular antigen. Now, the reason why this is really important, it comes in when you're having children. Okay, so here's the deal. The Rh antibody, the antibody can cross the placenta and destroy any Rh positive fetal cells, resulting in death. which means if you have a woman that is Rh negative, you want to make sure that you're testing her baby if her baby comes up Rh positive, okay? We'll talk a little bit more about that in the future, but it's known as hemolytic disease.